So we'll move on to the next session, which is talking about the stainless steel in chemical and petrochemical industry. And leading that panel with me is, so we have Mr. Yatinder Suri with us. He'll be moderating and chairing the panel. And along with him, we have Mr. C.H. Thanki, Director and Principal Consultant. We have with us Mr. V.P. Krishnan, Advisor, Engineers India Limited. We have Mr. Raghav Asthana, General Manager Projects with SRF. And we have Mr. Devender Devaria from GSL Special Products Division. I'll request all the panelists to join us on the stage. In this session, we do have a couple of presentations, and I'll leave it to Mr. Suri to decide the order of the presentations. I think, Mr. Suri, you are going first with your presentation? You're starting with the presentation?
Yeah, good afternoon. Of course, we are not very encouraged to see a very, sprinkle of an audience. But I'm thankful to all those who are in the audience who seem to be interested in the subject that is under discussion, and I'm thankful to them. Before I start, let me amend the corrections, the mistakes. We have Dr. G.H. Thanki. He is not Mr. something Thanki said. And then we have Dr. R Krishnan. So they are all very enlightened panelists amongst us, and I think we should ensure that their names are taken correctly. So let me start with the introduction. I think I'll go to this is the panel discussion, basically stainless steel in chemicals and petrochemical industry, moderated by yours truly. I have written my designation as co-chair CII National Mission on War Against Corrosion. I think once we start discussing the subject of corrosion, stainless steel would automatically find its position of prominence. And I'm very happy that the largest stainless steel company in the country, namely Jindal Stainless Limited, decided to support this war, this mission on war against corrosion. And I'm thankful to the MD, Mr. Vijay Jindal, who took keen personal interest in making sure that the national mission takes off from the ground. The panel members are Dr. G.H. Thanki, his Director and Principal Consultant, Dr. R Krishnan from EIL. Mr. Vijay Kumar Gupta is not there, but Mr. Devender Devgan from Jindal Stainless, their General Manager, Special Steels Development, is here amongst us. If you could raise your hand, Mr. Devgan. And we have Mr. Raghav Asthana from Shriram Fibers. So these are the panelists that we have today. They are all experts in the domain. And why this session on stainless steel? Why we are discussing stainless steel? So, as I said, I would like to talk about corrosion so that stainless steel automatically becomes the hero. Corrosion is a universal phenomenon we all know. And why it happens, that also we know. Corrosion is something which is unavoidable. What we can do is we can try to mitigate, we can try to reduce. And India's total cost of corrosion is almost 4 to 5% of GDP. Just look at the number next to it, almost $70 billion. And if you start converting it into rupees, multiply by 80, you have a whooping big number, which a nation of our size or of the status that we are in right now cannot afford. It's a massive drain to economy, causing billions of rupees of losses per year. And now that I'm talking about it, the good news is that the Prime Minister is also aware of it, Niti Aayog is also aware of it, and they are all supporting the national mission on war against corrosion at this point of time. The cost of corrosion as a percentage of GDP for Japan, as you can see, is 1%. It's less than 1% actually. USA is 2.7%. Europe 4%, but the global average is 3.4%. So can we not be close to Japan, which is 1%? Very ambitious target. It's not something which can be achieved so easily. Maybe first step is to come to the global average, and then next to beat USA, and then come closer to Japan. So how do we do it? So understand corrosion economics to develop mitigation mechanism. That has to be our methodology, from reactive corrosion management to proactive corrosion management, and understand and address corrosion issue with appropriate material science solutions. So once again, to repeat, JSL is supporting this mission, and again, we are very thankful. Why the national mission? You look at the principal objectives: to promote and facilitate anti-corrosion interventions. So anything which corrodes, you try to intervene and stop it, or at least reduce it. Across the Indian industry spectrum, as well as agriculture and services. This corrosion happens in agriculture, it happens in services, and it majorly happens in the industry. So that's why I have listed down all the three areas for you to understand it better, not that corrosion happens only because of industry. To encourage all sectors to embrace a new strategy within their organizations. It's not just, one company is doing it. Of course, a few companies are doing it right now, and they are doing it very well, which we will come to know during our one of the panel presentations. So, with very good results. And if we follow their methodology, I'm sure India can come very close to USA or maybe close to Japan. So, corrosion management framework to manage the threat of corrosion to assets. We want our assets to perform as long as they can. And creating awareness, not only amongst you, but also amongst the people, amongst the engineers in the organization, training them and waging a war against corrosion. So for this, if we have to seek active cooperation of R&D entities across the world, we are ready to do it. We are ready to pool in their wisdom so that Indian stakeholders gain in the end. The actions needed to make, in particular, we are talking about today in this session, chemical, fertilizer, and petrochemical sectors. As we all know, the chemical sector, we have very high temperature processes, which are the greatest source of corrosion in the chemical engineering sectors. There are complex units containing multiple tubes, bends, and all in hidden spaces, within the heat exchanger, within a reactor, and things like that. Mitigation involves careful material selection, and I've added here weld support. If you do not weld stainless steel with the right kind of electrode, you are going to ruin the stainless steel that you're using. It's going to fail very fast. So the fabrication of stainless steel is equally important besides the material selection aspect we all talk about day in and day out. Initiating understanding of corrosion management with individual roles and responsibilities. When we talk about our technical engineers on the shop floor, we talk about technology people, R&D people, it is very important that they understand what is corrosion management, including the top management. Create sufficient corrosion management resources. If you have no engineer in your company, you cannot say that I can tackle corrosion. You have to have qualified people, trained people who will take proactive actions to ensure that corrosion doesn't happen in your organization. Arrange adequate training of existing resources. If people are not aware of corrosion, there are any number of corrosion programs that are happening. Send them across so that corrosion understanding within the organization can improve with the existing resources also. Management review to show commitment of the top management for implementing corrosion management systems, basically to find out what are the non-conformances and preventive and corrective actions, audit results, KPIs, key performance indexes, whether they are being followed or not. So it's very important that management review happens. So aim is to ensure longer equipment life with minimum corrosion losses. Now I'll give you a little bit on the growth of Indian chemical industry. I had a short note for myself. Indian chemical industry is a major player in the global industry, in the global arena. Ranking third in Asia, and India contributes 3% of global production as far as chemicals are concerned. Indian chemical industry comprises of various segments such as oil and gas, midstream refining sector, downstream petrochemicals and plastics, polymer sector, inorganic and organic chemicals, including specialty chemicals, fertilizers, both phosphatic and nitrogenous, and precursor for energy sector like green hydrogen we discussed by electrolysis, etc., etc. Now, the chemical sector also provides building blocks and raw materials for many other industries like agrochemicals, pharmaceuticals, textiles, paper, cosmetics, pesticides, mineral processing industries, etc. The specialty chemical sector, which Raghav comes from, he will be talking about it, is growing at fastest rate and is expected to add $80 billion worth of production to reach annual sales of $300 billion by 2025. I will not touch upon the oil refining because that's not a part of the panel right now. But the per capita consumption in India for petrochemicals and polymers will see steady increase due to demands from growing population and their per capita income. This industry also is estimated to witness addition to the tune of $30 billion from present turnover of $190 billion. Coming to fertilizers, India ranks third in world and is likely to see moderate expansion in the field of urea production and a few number of projects in the field of phosphatic fertilizers. Lastly, but very important, will be the huge contribution expected in the field of green hydrogen involving investments of $19 billion by 2030, which will keep growing beyond 2030. To summarize, the Indian chemical industry will continue to grow at faster rate than the last 10 years and would contribute more to India's GDP and employment. You know how many sectors it is supporting and how vast this sector is. Therefore, ladies and gentlemen, is this not perfectly in order that we protect these assets that we already have in the chemical sector for the long term and also invest as we go forward? Whatever we invest wisely with life cycle cost in mind. Going forward, stainless steel, I'm sure, will ensure this. I was talking to ex-secretary Mrs. Aruna Sharma, who just stepped down from the dais, and she said, although the general finance rules do not use the word mandatory as far as life cycle cost is concerned while formulating a project, but you can always go and put a fear in the minds of decision makers that if it is found at a later stage that you have ignored life cycle costs and you have spent more money than what actually should have been spent, and there could be an action against you going forward and your life could be miserable, probably this threat can work. So she advised that we use this threat strategy to ensure that people go for life cycle cost while evaluating new projects. So with these words, it is time to listen to the experts. We'll have Dr. R Krishnan talking on material selection with emphasis on the life cycle cost. Dr. Thanki, he will talk about cost of corrosion in industry, corrosion audits and corrosion management. Mr. Vijay Kumar Gupta has not turned up, so instead we have Mr. Devgan, who is going to speak on special stainless steels, which can be used in the chemical sector as substitutes to the regular ones that we have been using for so long. And then we have Mr. Raghav Asthana, who's going to speak again on life cycle cost-based material selection, safety, and new investments in Shriram fibers. So with these words, I first request Dr. R Krishnan who's ex-ED, Engineers India Limited, a very, very renowned engineer, metallurgist from IIT. And over to you, Dr. Krishnan.
Good afternoon, gentlemen. I am a metallurgist. Naturally, my bias will always be to use a metallic material to the extent possible to meet the design requirements. Well, you do the first activity of any project after project viability studies is to do the process, detailing of the process, make the process flow diagrams and sizing of the equipment, etc., etc. Once those basic inputs are available and the process conditions are available, process conditions means the fluids being handled, the temperature, the pressure, and the flow rates, etc., is available, then we have to see the effect of individual process parameters on the materials to be chosen, whether the material that is being chosen is capable of handling the pressures and the temperatures associated with the process design, and what are the purity levels expected for the final product that will be coming out of the system, of the unit process system. What is the safety risk perceptions of the management, how much risk perception they want to use, and what is the capex limitations that they want to impose on the materials, on the overall project costs or the unit costs, so that it becomes within, well, it falls within their budgetary estimates. All of them are influencing the material selection to be made. Once we try to choose the material, the first workhorse material, which is carbon steel, which is the cheapest, about which we think we know a lot of information because everybody is handling it, is the first choice. But when you do the test for that particular material that you choose, or carbon steel of some particular grade for a size, like if it's a plate or for a piping or a pressure vessels or a tankage, once you choose that cheapest material, or you consider the cheapest material available, then you find out from the various published information or so-called corrosion tables published by individual companies, individual pioneering corrosion study laboratories, etc. What is the corrosion rates? Then you try to accommodate the corrosion for and compare it with the life cycle, design life of the equipment that is anticipated. When you do this particular aspect, if the corrosion rate exceeds corrosion allowance that is required for the lifetime expected, exceeds 3 millimeter, you go to the next material. The next material is automatically, a carbon steel will get upgraded to low alloy steels. A similar exercise is done, then to high alloy steels. Then you go, the next alternative is to lean kind of stainless steels, which is having much lower corrosion resistance because of the presence of chromium, which forms a very tenacious and continuous layer. Basically, it's a corrosion layer. Chromium becomes chromium oxide, and when it is continuous and impervious and it is tenacious, it stays permanent. It prevents further corrosion beyond that layer. So because of that, it's stainless nature. That particular material is chosen so to avoid the corrosion allowance completely. Also, whenever corrosion occurs, even if the corrosion allowance is tolerated, and you are giving corrosion allowance for the number of years that you want to calculate, the corrosion products are going to affect the product quality, final product quality, or if it is going to poison the various the chemicals that are used, the downstream, then that particular material, even though corrosion rate is tolerable, because like in the case of pharmaceutical sectors, in the case of food processing sectors, in the case of certain high purity chemical sectors, then this particular no material that is likely to corrode, even though corrosion allowance is possible, is to be chosen. So automatically it gets upgraded to stainless steel. Similarly, in the case of when the hydrogen is present, or hydrogen sulfide is present, or sulfur is present in the process stream, beyond certain temperatures, it becomes unviable to either to have the corrosion allowance possible, or to tolerate the corrosion products in the final stages. Under those circumstances, it becomes necessary to choose a material which is basically stainless. But stainless also got various. There are more than about 42 grades of stainless steels are there. They have lean stainless steel, to ferritic stainless steel, to martensitic stainless steel, austenitic stainless steel, super austenitic stainless steel, duplex stainless steel, super duplex stainless steels, hyper duplex stainless steels, and some specialty steels which are much higher. Basically, all this upgradation is based on the extent of the alloying content: chromium, nickel, molybdenum, and rare earth elements, and some additional like tungsten to import some specific properties. And in the chemical sector, as I told you, the chemical corrosion tables decide, give you guidance on what are the corrosion rates at various temperatures, and whether they are prone to corrosion in the case of a certain when it exceeds the velocity, fluid velocity, or are they prone to pitting if they are going to remain stagnant. All these things ought to be taken into account when you are choosing a material. And in general, where the pitting tendency is high, the ferritic stainless steels, especially in chloride environment, in the chemicals contains chlorides, and the temperature is also increasing, and the moisture is also present, then the pitting resistance has to be imported. The ferritic stainless steel has got a very good stainless pitting resistance, and from let's say 12 chrome, 13 chrome, 17 chrome, 22 chrome. These are the stainless steels which are in ferrite phase is stable at all temperatures, and they can be used up to a temperature of 400 degrees centigrade or 380 degrees centigrade, subject to the earlier conditions of the corrosion rates are within the limits at that process conditions, and the corrosion products are tolerated by the final product. But ferritic steels, even though they have got very high chloride resistance, it is not possible to use it in all conditions, because the fabricability and its mechanical properties are suspect, especially as the temperature increases. It starts decreasing. And under those conditions, the austenitic stainless steel grades, which are chromium, nickel, they are only pure chromium grades. They are ferritic grades. And when the carbon content is increased in those ferritic grades, they got a very high strength. They can be used for high erosion resistance associated with the chloride content also. Then they are called martensitic stainless steels. So martensitic stainless steels are cheap, but you still have difficulties with the brittleness and hence fabricability in all the forms of our choice. So the austenitic stainless steels, in comparison, are having chromium, nickel, and molybdenum if to import some special high temperature properties. So they are very malleable. They are highly ductile, and they can be formed, they can be easily welded, they can be easily fabricated. Because of that, choice would fall on the austenitic stainless steels, even though they are higher cost because of the presence of nickel or molybdenum. These are preferred materials for general ease of fabrication and ease of operation. But there are some areas, in the austenitic stainless steel grades are 18.8 base grade, which is workhorse grade in austenitic steel, 18.8, that is a 304. Then 304, when the stabilized grades are called, with titanium is called 321, with the niobium is called 347. And when the molybdenum is added for importing specific corrosion resistance or high temperature properties, it's called 316. And when the carbon content is controlled to give better corrosion properties under certain conditions, it's called LL grades. There are low carbon grades, 316L. Like that, then titanium is added to stabilize. Those kind of things we can take up in a different forum on the different grades, how it is. So 317 Ti with the titanium stabilized stainless steels. And these are the basic 18.8, around 18.8 it is built. So these austenitic stainless steels are very good at high temperature properties, got higher, very good corrosion resistance properties under various acidic and alkaline conditions for many fluids. But they are also prone. When the chloride is present and beyond 60 degrees centigrade, it becomes prone to stress corrosion, chloride stress corrosion cracking, and because of that, they are not used in their solid form. Either they can be used as a clad form, base material, backing material will be a cheaper material like carbon steel or chromoly steels, which can withstand the higher temperature and higher pressures, etc. And the face of the plate, the component that faces the fluid, operation fluid, will be a higher stainless steel, it will be used. So then, as a temperature for a number of chemical and petrochemical processes involving very high temperature processing, like heaters, heat exchangers, you need very higher temperature properties, like fired heaters. So, fired heaters, in the absence of H2S, the 9 chrome, 13 chrome can be used. But in many cases, it's not only the composition of the initial starting chemical or composition of the final chemical product is to be taken into considerations. During the intermediate processing, when the reaction occurs in a space like a reactor or a tube or a heat exchanger or a heater, there could be some intermediate. The reaction is completed in steps. If any one of the steps is going to produce a transient chemical, which is likely to cause corrosion based on the corrosion tables that I referred, then you have to take that into consideration. And second, and also, when there are some conditions in which the plant is being shut down for maintenance, at that time, when it is open, some kind of moisture can enter into the place. When the moisture and the corrosion products that are existing can combine together to produce specific conditions like stress corrosion cracking conditions. Under those conditions, you should avoid those materials that, even though they perform well during the operation, during the shutdown period, they are prone to suffer the kind of stress corrosion cracking. So all these things will affect the integrity of the plant once you restart it. So the stainless steels that was chosen should also be capable of handling all the transient chemicals that are likely to be produced in the chemical process, and also capable of handling the strange situation that can occur during the shutdown or maintenance areas. So this is therefore material selection is a pretty all these things ought to be taken at the start of the. You have to consider while even the starting of the finalization of material selection diagram. So it requires quite a deep knowledge of various processes and the effect of the various chemicals at various temperatures and various pressures on the various materials that are likely candidate materials that we can consider, and the corrosion mechanisms, material deterioration mechanism that can occur during the life cycle of the unit till it is even beyond. Quite often we want to extend the life of the units beyond its design life. Therefore, you see, the panacea, normal, in the case of refinery operations, the water plays a major part. Water-based electrochemistry controls most of the corrosion status. Whereas in the case of petrochemicals and some, especially where our chemicals, that moisture is not a major constituent there, because we don't want moisture in the system. But there, it is much more complex. Even though it is dry, the corrosion occurs. This corrosion is not very much, it can vary from place to place, and it requires a very detailed study. And when in doubt, we always go for stainless steel. And yes, in stainless steel also, if you see the previous published information whether such material has really suffered any loss of health during its lifetime based on the published information. If such occurs, then we try to do further studies and to find out which is more likely candidate for the material, for the material of construction. And when you do the we do the material selection study. We got material, you establish, first you say material selection philosophy based on what the management wants. Management wants to say, no, I don't want any costly material. I want this much life, and I don't mind changing every 6 years or every 10 years. Then you put that in writing, then accordingly you choose the material based on the criteria that I have told, how much corrosion allowance we can give for that life expected when they want to change. Then later it should not be coming on the material selector that you have chosen a wrong material, it has failed. But once you want 25 years life or non-stop operation or no contamination or highest safety levels. So the risk-taking perception of the management also is taken into account while doing the material selection. The material selection philosophy is first is put down in writing, then material is selected, then you do the material selection diagram is done the material selected is posted on the process flow diagrams. And then finally you say, you also give warnings. This is can happen after 6 years, this should be changed. Or it should be inspected periodically. The corrosion product should be monitored at the end of at these locations. All these things form basis of. But when you choose a stainless steel, many of the things are avoided. The another thing is wherever the corrosion allowance is given, the corrosion rate is to be controlled by injecting some corrosion inhibitors. Now you need to have additional facilities for storage, dosing, and corrosion inhibitor piping systems. And you at the end of the cycle, the corrosion inhibitor has to be removed from the system. So the disposal of it, all of them involves costs associated with the corrosion control. While selecting the material or when you do the material selection, you should also do the corrosion control philosophy and corrosion control procedures, and the cost of this should be added to the overall cost. See, therefore, conducting a life cycle cost analysis is a very prudent way of doing an optimum material selection. When you do the life cycle cost analysis, then you will know what is when you add all those costs, initial cost, as somebody else will be talking about it, replacement cost, what is the material of that at the 6 years later, it could be an escalated cost, then fabrication associated costs, and the chemical cost for injection, the chemical, the cost for the establishing the chemical injection system, cost for removing the chemical that is added for the corrosion control, and also the disposal of those chemicals later. All these costs ought to be added to this. When you do this, quite often we find that stainless steel is used, becomes a very more viable one, and you choosing the right type of stainless steel based on the knowledge of the material selector becomes a very essential thing, and all these things ought to be kept in mind while you do the material selection for our industries. I think it's just a glimpse of what we need to take into account doing a material selection, and I leave the podium to the...
Thank you very much, Dr. Krishnan. Yes, it's such a vast subject. I think doing justice in just about 15 minutes is practically impossible. It's like the tip of the iceberg, a lot of more information is available. You want to know it, contact the domestic producer, Jindal Stainless. They also have very fine brochures. Or you have Outokumpu office here, where you get a very nice corrosion handbook, which gives you so much of information on how corrosion happens and what are the factors which should be taken into account for various diverse industrial segments to select the right material. So information is available. We are very happy that Jindal Stainless is there, Outokumpu is there. Please make full use of their presence in the country. Thank you very much, Dr. Krishnan. We are really, very thankful to you for touching upon so many different aspects of petrochemical and chemical. And
material selection sessions should be for specific unit, specific equipment. Then we can have a lot of information exchanged easily. And difficulties faced by them also can be answered in future sessions.
Right, so that's the plan going forward. With the support of Jindal Stainless, CII is going to do many things which will be unfolded to you in due course of time. The next panelist who is going to speak on cost of corrosion and corrosion management system, which is very important and which is going to be the way of life going forward, I would say 1 year from now, because there will be many interventions at the policy level, and there would be a lot of support from the Niti Aayog. So good times will come for corrosion management system implementations, which would lead to a lot of demand for exotic materials, stainless steel being the most preferred out of them. Over to you, Dr. Thanki.
So, my dear audience and my fellow panel members and my senior leader, Mr. Suri, I will just shift from the oral discussion we are talking about the particular material construction and its limitations. I will just put different way how all these problems what we are facing in day-to-day various chemical process and petrochemical plants, everything is will be taken care by a simple single word, corrosion management. Then how it will encompass, I will give you a different way this matter. Next is how it goes. Please next. How would I? First is single, one only. Now you will wonder what I have shown to you. Can you imagine? This is a footprint of an elephant. Would you wonder why I have put an elephant over here? Next one is elephant. Next is showing its lag. And what I'm trying to look at it is like elephant footprint encompasses all animals' footprints. Corrosion management covers important discussion points like, next, here is the corrosion specific and management system elements, which we are going to discussion points like cost of corrosion in the chemical industry, corrosion resistant materials in the chemical industry, life cycle cost-based material selection, safety, hazardous environment, corrosion audit, cost of corrosion on a part of balance sheet, lost production due to downtime due to corrosion, carbon dioxide footprint, sustainability, and stainless steel usage. Then last 4, chemical industry growth, new investment in 2025, and global use substitution example. Out of these all the 10 points, previous one, yellow color 7, will be taken care by if corrosion management is in place. So you should understand corrosion management what it is. So it will take care of all the problems and nightmare of the maintenance engineers, mechanical engineer, chemical engineer, downtime of the plant if corrosion management is true. So next one, please. Corrosion management, please, go back. Corrosion management must be made priority and included in the policies, strategies, and objectives of the organization. The first step is to define the corrosion risk, which we are discussing till today. Then define how to reduce those risks, the metrics for measuring improvements and calculating LCC and ROI. So here I am going to stress on this one. I will be taking all the 7 points only in corrosion management. I will not be speaking to various aspects independently. Next. Establishing a robust corrosion management system. Next. A corrosion management system is considered one of the indispensable elements of a successful asset integrated management system. Hence, it is imperative to ensure that a corrosion management system is in place, adequately integrated and operationalized. Now, what are the key steps in establishing a corrosion management system? Establishing a corrosion management system is a long-term process that starts from the concept design phase all the way to the asset's end of life. It is always recommended to complete most of the corrosion management system elements during the detailed design phase, from where the corrosion starts. Detailed design is not done, corrosion will be going unabated. To allow for gaps in the design to be mitigated in this phase and prior to the completion of construction. However, the various elements of the corrosion management system can still be developed during operation if deemed necessary. Next. What are the main challenges in establishing a robust corrosion management system? The establishment of a successful corrosion management system is not a straightforward process. And as with any other integrity managed processes, challenges are usually encountered during the development and implementation phase. These challenges are widely manifested throughout the following areas. First is, next, strategy to be established, human factor, next, data gathering, reporting, and competency with, next, financial. Now, out of this, next, go back, please go back. Out of this, what I have found in my long experiences, human factor is a major factor. For example, best way, if it is done by the Jinnah Steel or the or the people based in Sweden, material are fine to be made. But this cannot be utilized just like that. It has to be fabricated. And during this fabricator, human factor comes in, unless a robot are there in case. So corrosion starts with the human factor. Out of this many statistical studies are done by, 43% of the failure are because of the human factor. Next. Now, a pathway of corrosion management. Corrosion management policy display. One by one, please. Corrosion management policy display. It has to be displayed in the entry gate of the company in the various places, which I am talking to you with my own experience as a corrosion management advisor to the Indian companies. And I can say they reap the fruits of this one. Display makes perpetual awareness about corrosion. If I say so, we always say the corrosion is a natural phenomena, which cannot be stopped. Now, when we talk of natural phenomena, it means what? It is the nature has got two basic characteristics. One is a consistency. Sun rises every day since billions of years. Again, there's got discipline. It rises at exactly that time. If corrosion is such a natural process, man has to follow that same thing to control corrosion. Today you have control, and tomorrow you are forgetting. And that's why corrosion monitoring system and online real-time corrosion monitoring system has come to play, because of human factor is not reliable. So, first thing what I say, if it's corrosion is to be controlled, every day we have to think about corrosion. So you must have the corrosion management display. Now there are various ways to display. That only a matter of more details. Those who are interested, I think they can contact our CI Corrosion Management Division, and we'll be happy to help you out. Second is corrosion control awareness. It has to be continuous, day in, day out. It is the prerogative of the management, not the control someone engineer, mechanical engineer, chemical engineer is going to take the control. Management has to understand how much corrosion is taking the stock of their product, policy, purity, and reliability. Next. Reduce by extending life of metal objects and parts. Next. Like this, reduce, reuse, and recycle. That is, we have discussed a lot in our previous various presentation. Next. Corrosion warriors identification. To have people to have the perpetual awareness. They are the connecting chain between the management and plant corrosion problems, which I could identify from the process engineers. That means chemical engineers, mechanical engineers, civil engineers. We have to identify the people. And what we did, we also had purchased the T-shirts having embossing corrosion warrior. There are 5 or 7 persons, or 10 persons are there in the company. When they walk through, people because I did it. I did it with the United Phosphorus since last 2 years. And we are reaping a lot of fruits. I'm very happy. I'm very happy in the sense that I was permitted to apply this corrosion system. A company had come forward. Now you might be knowing United Phosphorus Limited, the 65,000 crore company, having 14 to 16 companies in the country. Throughout the world, there are more than 32. They are the people of agrochemicals. And when we are inviting some vendor to discuss certain product, they first get little alert. They have got the corrosion warriors. So we are not going to talk something nonsense. They are there. So corrosion warriors make people feel. For example, if you have got your own family doctor, and through family doctor you talk to the outside doctor, that doctor will be very careful because family doctor is going to watch. Are you giving the right type of medicine, costly medicine, right? All these things are there. Here is what we did, and I think this corrosion warrior word is very important. Next. This is change what I am trying to show. Next. Corrosion museum development. We got collected various failed components. Please don't go ahead. Go back. Corrosion museum development. That means we are collecting the failed component with a prehistory, displaying in a particular place, which is nearer where plant people are meeting. For example, near to the canteen, entry gate, like that. And they always see, looking to that one, that this is a pitting failure. Why would it fail? Because it was taken care like this. So continuous hammering in the mind, because we are forgetting about corrosion. When we become healthy, we forget about what should be our lifestyle should be. Like that is here. Then comes the corrosion control documents, which includes the damage mechanism. Here CCD we prepared with all the critical equipment, and it is just like a Janma Kundli. Right from the fabrication point of view, throughout his life, what type of failure had taken place, why it has taken place, what are the mechanism. It tells you prior discussion why and how it is going to fail. So it is very much with the reality. Next. Life cycle cost. I will not talk much because we have discussed a lot. But life cycle cost means what? Next. It is the life cycle cost, initial life, end of life, then all the cycle is to be completed. Next, and continuous improvement. These are the points which has to be put. I am telling you from my experience only. This is not from the books. So I got experience. So if any questions are there, definitely CI people definitely come forward to help you out. Next slide. This is epilogue only. Next. Realizing the maximum benefit in reducing corrosion cost, both direct and consequential, requires more than technology. Let us talk more than technology. It requires integrating corrosion decisions and practices within an organizational management system. Managing director, chairman of the company, he should be there within that one. Buck stops there. Because we talk only pitting corrosion, we talk about stress corrosion cracking. We don't have any decision-making process unless management is there with us. Next and last, the corrosion professional should broaden his competence with respect to business tools to include financial decision-making, risk assessment, and management systems. Use of financial and risk assessment tools should be a normal and expected activity for evaluating corrosion control expenditures. Corrosion control expenditures aids in the life cycle cost. It goes on the ROI also, return on investment. Next. So here just I am giving a Swiss cheese model, quite known to you people. For example, hazards are there. You are keeping decision making, material construction, you are stopping, trying to there, but again residual risks are there. Further, you are monitoring the system. Then you get an inspection to stop the corrosion process. Again, you get the mitigation, even though if something goes, an incident takes place. But these are the various barriers. Next. Swiss cheese model widely used in risk analysis and safety management. Next. The corrosion management is a system to assemble these slices, that means corrosion barriers, together to prevent the failure. Next. So now we are changing to the, which was given to me, 2 paragraphs are there, sir. I will not take much of your time. Cost of corrosion in the chemical industry. Next. The global cost of corrosion is $12.5 trillion per year dollars, which equates to 3.3 to 4% of global GDP and about 4% in India. As per the Corcoran Institute of Corrosion, the impact of corrosion on infrastructure has a fallout on the economy. Next. The total annual direct cost of corrosion for this industry, that means chemical industry sector, is estimated as $1.7 million per year. That means 8% of total capital expenditure, capex. Next para. This cost does not include indirect cost of production outages or indirect cost related to catastrophic failures. Next. During production of aggressive chemical like acids, the metallic equipment for transportation and storage is more likely to be damaged by corrosion process. This is the overall scenario of the chemical industry. Next. In these industries, corrosion causes huge safety and economic damages, including loss of life, adverse economic and social impact, water, soil, and air pollution that occurs during the production, processing, storage, and transport process. I have tried to squeeze out all the things which I experienced in my many years in the chemical process industries. I found these are really big impact. It makes really life very, very uneasy in the process plant. Engineers at morning 2 o'clock, they are calling you. And the corrosion man is required to be over there. Really, it is very uneasy time. But here only, if awakened people are there to manage the corrosion, then and there things can be controlled little. Next. Chemical industry corrosion is mainly caused by the liquids and gases used in chemical processes. They corrode the processing apparatus and the storage containers from the inside by attacking their inner metallic surfaces. 2 types of substance dominate the chemical industry: concentrated sulfuric acids and organic acids, each bringing particular corrosion problems. Next. Corrosion survey and audit cost of corrosion, part of balance sheet. Just 1 minute. This is the area where CII Corrosion Management Division has taken everything very seriously. And we as a team carried out at least 8 to 9 various sectors in the country corrosion audit, rather corrosion survey and corrosion audit. In this one, just like from the cradle to crematorium, cradle to grave, when material comes in the store system, it is quite fresh one. When it goes to storage or the area, which no management will show you to any visitor, because very ugly shape where things are being heaped up. So difference between two, you know, when any material is fast moving, why it is fast moving? Is it because of the life itself is expected this much, or it has been corroded before it was to be given their good services? So it talks to you about the corrosion control culture of the plants. You know the people, they only cry, but they don't want to control the corrosion. Here we talk a lot about corrosion, but it is not a matter in this hot sun with the steam ejecting outside and you are controlling corrosion. Here we are talking very nicely about this corrosion, but that ugly face are difficult to face, isn't it, Surisa? Next. Corrosion survey is one of the fastest, most effective, and least expensive methods to carry out corrosion audit of an organization's ability to control corrosion. We are trying to understand, are they able? People they say, no, can I reach to this particular place? How many days it will take? Then I have to walk with you. How fast you are walking? Then I can say 1 day or 1 hour. Like that here, corrosion can be controlled depending on the corrosion culture. Next. The insights gained from corrosion survey will help organization to cut cost, reduce its environmental impact, and improve overall safety. Next. If corrosion survey is followed by corrosion audit, it helps to bring the major benefits like identification of the silent effect of environment and process conditions, identification of design faults, determination of materials capability with environment, compatibility with environment, formulation of a reliability-centered corrosion monitoring schedule to minimize corrosion loss, economic impact, and plant outages on account of corrosion. I suppose this was the last, I believe. So, sir, it was my talk about, sir. This is over now. I tried to bring it this with a different way. I hope it is good in the mind, sir.
Thank you very much, Dr. Thanki.
Thank you.
In fact, as we have realized, many of the companies who opted for corrosion audit, and after seeing the report of the audit team, they were quite surprised that so much of losses are happening in the organization due to lack of awareness on corrosion aspects. So they took a note of the recommendations of the audit team which went from CII, and then they have taken corrective actions by replacing the materials with the right kind of material. As Dr. Krishnan explained, they analyzed the environment and they decided on the right kind of material to be used, leading to better performance in the years ahead. In fact, Dr. Baldevraj, who was, he was Padma Bhushan, Dr. Baldevraj, who was in charge for IG car, in the Kalappam nuclear plant, there was not a single maintenance downtime due to corrosion for 10 years that he led the teams over there. And he always used to say, it is all because I have chosen the right materials for a given application. So he was a fan of stainless steel, he was a fan of higher grades of stainless steel, and he was always in a learning mode on what are the new stainless steel grades available for more corrosive environments. So what I'm trying to say is that if the top management is very much aware to mitigate corrosion in the organization, a lot can happen to increase the use of stainless steel amongst the industry stakeholders. I will now go forward. So thank you very much, Dr. Thanki. In fact, Dr. Thanki has been a part of CII audit teams for many years, I would say for over a decade. He was one of the pioneers to undertake this activity, and we have a lot to learn from him going forward. So we now have Mr. Raghav from Shriram Fibers, specialty chemical industry. So let's learn from his experiences. He is a shop floor man who's going to talk about corrosion, who's going to talk about material selection, and who's going to talk about safety and life cycle costs in a short span of 15 minutes. Over to you, Raghav.
So, good afternoon, everyone. Hope I am audible to everyone. A very warm evening to my fellow panelist, Suri Saab, and to the audience. So, at SRF, we are predominantly a chemical-based company which are into specialty and pharma chemicals and also bulk fluorochemicals. Other than this, SRF also have packaging film business and technical textile business, which are a part of its overall portfolio. So I come from the background of a specialty chemical, and where we particularly making agrochemicals and specialty chemicals, which goes as an intermediate to various of the pharma and agro final manufacturers across the globe. So the topics which are here is one is life cycle cost based material selection. So as my fellow panelists have covered a lot more about the corrosion things which are there, which are associated with various of the chemicals which are being used as a raw material or at intermediate stages which are getting formed because of the various nature of these chemicals. They are very corrosive in nature. So to have a right kind of items at right places, right selection of material becomes a very, very important thing to do in these kind of chemicals. So life cycle also is an important factor. So once we say about life cycle, it's not only about the overall cost of an item taken for its lifetime. It's a component-based cost. Let us take you through. So it's all about initial material acquisition cost, the part once you acquire any material or a raw material for anything. Then it takes you through the material fabrication and the installation cost, which is also a part of it, which is incurred by the plant owners, which goes into it. Then comes the cost of its operation and maintenance throughout its life cycle. It's not that the things are completely worn out, so they may require a little maintenance, work for a little while, and then so on. So it's also about the operation and maintenance cost you might be incurring on that machine. Then if those machines are under breakdown or under downtime, there is a lost production which is associated, and this production cost is very huge as compared to the initial machine cost. So life cycle cost must encompass these lost production cost. Then there is a replacement cost which should also be a part of this life cycle cost, because if you have to, if there is a thing or item which has prematurely failed and you have to replace that material before the life span of that machine has ends, then there is a replacement cost, and it could be similar to what you have initially purchased, or it could be many more times if you are changing the metallurgy of that. So a few examples which I would like to demonstrate here from the chemical industries. So this is of a brine pump impeller. So generally these utility pump impellers comes with bronze metallurgy. So there was a pitting corrosion which was seen. It runs at around minus 25 degrees centigrade, and there is a huge pitting corrosion which was observed in these impellers. They runs at a higher speed. So what we did is that we changed the metallurgy to the stainless steel, and this failure has happened almost within 2 years since the pump was installed. And once we changed this pump impeller to stainless steel, it has been running more than since 10 years, and no problems were faced. Next is example is of a multi-effect evaporator, calandria tubes, where the corrosion is a very natural phenomena, because in these calandria, the wastewaters are concentrated and then taken out. So as soon as you go the stages up in the calandrias, the concentration of chlorides, etc., increases, which results in premature failure of these tubes, which was never intended. So as a material of construction, we have initially used SS316Ti, which was meant to resist this corrosion. But later we have to change this to duplex stainless steel, where it is still working, and we find this. Next is, there is a distillation column where the service was a little foul. I would not say that it is completely foul service, then probably the material of construction would have been wrong. It's a little foul, so the initial thicknesses which were predominantly given by any column internal manufacturer is like 2 mm, and the packing thicknesses range, random packing thicknesses range from 0.3 mm. And within a span of 2 years, the packings were worn out, the internals were worn out, and we had to change them. Though the initial column MOC which was there, it has worked well, but the internals were not of the same nature when it was procured. What we did is we increased the thicknesses to 0.5 mm for the packing, and for these internals it was taken 5 mm, and the life which we have now getting is more than 5 years for these columns. So what I meant to say is that if we look at the cost of initial cost, whereas the replacement cost would have been, if we would have taken that decision initially, it would have costed us less 10% higher. But since we took a downtime and then replaced these, the ball game is entirely changed. It has been a lot of expenditure which has gone in. So this diagram which I have taken from World Stainless Steel Organization, it talks about the overall sustainability and overall cost saving if we go for stainless steel. So it talks about acquisition cost. If we replace the material with the acquisition initially with the stainless steel versus carbon steel, probably we can save a lot more things, and since it is sparingly used, the amount of initial tonnage will reduce. And stainless steel, a lot of recycling also happen, which will in turn reduce our carbon footprints also. The second point is your fabrication and cost of erection, so which will also reduce because initial tonnage will reduce by the use of these materials. These are durable materials. Then there is an operation cost which talks about maintenance and operations for any mild steel or these carbon steel materials requires a lot of painting, which takes a lot of budget in the overall operation cost of a plant. So if I replace it initially, a classic example would be the Indian Railways. If you look at all the railings, etc., and even the seats across the platforms have been changed to stainless steel from the previous constructions. That saves a lot over a period of time in terms of painting, in terms of their overall maintenance of these items. Then it talks about I think I'm not able to read it correctly. It's the overall protection cost in terms of the overall thing that you save over the downtime of that item. So if there is a downtime or the plant is there in the downtime, then probably there is a lost production cost. And the last is recycling. Since stainless steel scrap goes on a higher cost, there is a recycling that happens to these material, and you save on the overall cost of the material. So this is all about life cycle cost of stainless steel. And then since I'm from the chemical background, so there is a safety and a hazard associated with all the chemical companies. So SRF, we do a lot of HAZOP analysis before we start any project. The particular chemistry goes for these HAZOP analysis. HERA is done for the storages areas, etc. And still there are various chemistries which are not known, or there are complex molecules for which the corrosion analysis has not been done altogether. So once we are dealing with these kind of chemicals, we have to be very cautious. So let me explain this phenomena with the cost of accident. If there is a chemical company and there is a accident that happens in a chemical company, so there are, am I audible? So there are lots of cost that goes into a accident. So is it working? Yeah, let me just try. Hello? Is it working? Thank you. So if I talk about the cost of accident, so there are a direct cost and the indirect cost. So direct cost, if I talk about, there is a cost which is incurred by the enterprise. That is the cost of lost time, medical care and transportation cost, cost of overtime, substitution, disruption of production, material losses, repairs, compensation in terms of financial compensation to the resources, and other costs. Then there will be a cost which is incurred by the society, like cost of treatment. If there is an accident which has happened on a larger level, then there will be a cost associated with the society also. There will be treatments of lots of patients. Then there will be benefits which has to be incurred by the society or the insurance companies to these patients. Then there is a cost which is incurred by the victims and the families, like lost income, cost of treatments, rehabilitations, and others. Other than this, there are indirect costs, which are like lost morale of the working people which are there in a chemical factory. Then feeling unsafe while going to work. Loss of trust, loss of face value would also be there, because company talks about lot of safety, but in reality there is an accident which has happened, which has reduced your image to zero probably. And if I talk about last point, that change of government, so if I talk about Union Carbide kind of situation, if it happens nowadays, it may lead to even change of government for that state particularly, or even for the country also. Or if you look at the nuclear disasters like Chernobyl, Fukushima, there is a global image also, which also goes for a toss if something like that happens to a country. So if I talk about, so for any chemical companies nowadays, safety of their operations is supermost. So you have to have involved a lot of consultants outside, internal team leads are there, which talk about a lot of safety things which has to gone into. Then why stainless steel to mitigate process hazard? So many chemicals reacts with chemical, which is iron, which is present predominantly in carbon steel, and can react violently. It can liberate toxic gases, which are very, very difficult. It can lead to exothermic reactions also, like if I talk about H2O2, which is this hydrogen peroxide. It liberates nascent hydrogen in presence of these iron particles, and which may lead to any fire hazard. Sodium azide, it reacts violently with these iron particles in presence of water and may lead to some toxic gases which can be very fatal. Then there are, so stainless steel, if I talk about, it's very, very good for a large range of negative temperature application, cryogenic applications, where carbon steel may not find a place at all. So it's a very good substitute for carbon steel piping for a cryogenic fluid application. If I look at chlorine industry, probably they are still using a lot of carbon steel piping, 8333 grade, probably probably they can switch over to stainless steel very easily for these storages of these liquid chlorine gases and transportation. Then polymerization in presence of iron. There are a lot of chemical which tends to polymerize and create solids in presence of iron, which may lead to overpressurizing of the pressure vessels and may lead to failure of those things because of exothermicity, etc., which gets generated in these polymerization reaction. Then grades of stainless steel are very good for stress corrosion cracking. So if I talk about, there are higher grades like 904L, etc., which has a higher percentage of nickel, which are good to be used where stress corrosion cracking occurs. So probably 300 series is not that good, but if I go about for duplex, super duplex, higher grades of SS, they are good for stress corrosion cracking. Then galvanic corrosion. So in general, stainless steel is good for galvanic corrosion. Galvanic corrosion occurs when there are two dissimilar metals which are used for any equipment or something. Then there is a higher chance that one material will lead to leave in a conducive environment. It may tend to have galvanic corrosion over the other and may result in premature failure of an equipment. So these are the various use cases where the stainless steel can be used. And then all metals in general are good for static charge dissipation, but in chemical industries there are a lot of usage of lean acids which cannot be kept in metallic things. So where static charge dissipation gets a real problem. So preferred is to have some mechanism, either a dip pipe or something of a stainless steel which can dissipate, and which is a sacrificial dip pipe and etc., which can be used for dissipate charges, etc. That's it for now. So
yeah,
thank you
very much, Raghav. Thank you very much, Raghav, for a very elaborate technical overview from a plant engineer. You talked about the impeller. Which grade of stainless steel did you change over to? Yeah. Which duplex? 2205, okay. So by using 2205, the life went up from 2 years to 10 years. And that's very encouraging. And the tubes that you talked about, there also you went to duplex. So there also it was 2205? And what was the change in life pattern there? So from 2 years to 5 years. And that's also excellent. So, and your last slide was very informative. So thank you very much for sharing the technical aspects of, or the technical benefits that you derived by using stainless steel in your organization. I'm sure this will benefit your competitors as well, and also give a lot of talking points to the stainless steel producers when they go and meet the chemical industry participants. So thank you very much. So now we have a small presentation by Mr. Devendra Devgan on grade substitutions. You know, so far we have always been talking about ferritic, 304, 316, but then in the last, I would say 10, 20 years, the whole scenario has changed. So many new grades have come about, not only in austenitic, but also in duplex, also in ferritic, that a lot of R&D has been done by Jindal Stainless. So we would like to have a few slides from you telling the audience on the substitution efforts that you have done and what are the benefits accrued by the user of the stainless steel in his workplace. So please go ahead. Thank you.
Good afternoon. Am I audible? Hello? Am I audible now? Okay. Yeah, good afternoon. And basically, good evening. Okay. And thanks to ISSDA for giving me the opportunity to share some of the case study from the industry. and thanks to the fellow panelists. And it was quite a heavy session with a lot of technicals and all. So, but I noted one point that we have been taught from the starting initial years that corrosion is a natural phenomena. By this statement, like we accept that corrosion is going to happen. So I think the statement, we have to get rid of this statement that corrosion is a natural phenomena, but there are ways and means that could be avoided. And by right material selection, this phenomena can be overcome at the inception stage. Because there is one is the rehabilitation after an accident or some event take place. One is at the inception stage when you select the right material. And I don't have any doubt that right material is not selected for the process equipment, because where the process equipment, critical equipment, there the material is very rightly selected. And the earlier, basically 10, 20 or 30 years back, those materials or higher alloys were not available. Even and now, since more and more alloys, super alloys, various variety of stainless steel grades are available, and the statement that needs to be changed, because like we call it workhorse grade 304316, but now there are many other workhorse grade which basically perform much better than these grades. So okay. These are some of the, like, what is the problem with the corrosion? It is my fellow presenter, and during the day, these have been deliberated. But basically, like, one is a threat to the plant integrity, and then, like, your equipment availability is on the lower side, recurring cost. And a plant operator or the workforce shift is more towards mitigation rather than running the plant or the productivity. That is the one thing. Next, I will go through some of the case studies. Okay, some of the case study where stainless steel lower grade basically grade upgradation from lower metallurgy to the higher metallurgy, or carbon steel to the stainless steel in various application areas. So this is one example, like this for the IOCL, where the raw crude oil is stored in the floating roof tanks in Paradip, where like the top skin plate of the shell was frequently painted, corroded, then again painted, then replacement. So these tank capacity is 80,000 KL and much larger than that. So if you have to do some repair, welding and all, you have to basically empty or that oil to some other tank, and tank goes out of the service for maybe 6 months or 1 year during this maintenance cycle. The kind of, basically it is out of service, it is a cost. So there, like, we worked with the IOCL team, and then they, like, we shared some sample coupon, they established, and basically find out that material is better and it is performing those environment. Then they installed this stainless steel plates on the skin plate. And after a series of tests and long evaluation, now they are going ahead with this basically grades, and they have they will be replicating in future in other areas, because process equipment you take utmost care at the design stage. But what about the walkways? What about the other balance of plant areas? Those are basically an area where you try to optimize on the cost. So those are the area where mostly accidents happen and are the neglected part. You have to do frequent painting. So that is one area where stainless steel needs to be added or needs to be basically used upon. Next is another example. It is a global one where after, like, they've used this ferritic stainless steel for 20 years of life, and it is pick and span. No corrosion was observed in a wastewater treatment plant. Same, like, where carbon steel was replaced by duplex stainless steel for the pipe AFFF piping and IOCL and other oil and gas installation. So there also basically they had a frequent corrosion, and now it is a practice, or it has become a part of a new specification. Now this is another where the dam water pipeline after a long service is still in the running, and it was designed with stainless steel for 60 years of life. From the carbon steel, they have shifted. And it has increased the efficiency because the surface roughness of the stainless steel is much better, much lower than the carbon steel. So you save on the pumping cost, you save on the replacement cost, and it is a fit and forget solution. The similar can be replicated in your fire piping or other areas in the plant. Another is like crude piping, where basically natural gas piping, where the soil was corrosive and the gas had various chloride and contaminants which were sour in nature. So there basically duplex stainless steel was used. Now this is another example of life cycle costing. There's a recent in Versova wastewater treatment plant in Mumbai. So this photograph were taken in the Jan 2023, when basically this equipment, this plant was decommissioned. So it is after 23 years of 27 years of service life. These are 316L equipment. So you can imagine, like after 27 years of life, they are right next to new. And what kind of like salvage value? One thing, after the end of life, there is a salvage value of stainless steel. So when they were bought, and today you can understand that nickel 27 years back, or raw materials at that 27 years back, and today so it has a good residual value. Then another one case study is, this is a lean duplex in basically PTA silos, where 304, initially the design was with 304, then basically owing to the weight saving and advantages of the high strength and corrosion resistance, part of the quantity was changed into the lean duplex. And here now it is under erection. And this will be like one of the good example where weight saving of lean duplex had given us overall, saved the overall project cost overruns. So the idea is that there are variety of grades, and basically it's right selection at the time and evaluating which grade suits. And because one of the mindset is stainless steel is expensive, but when it is over the life cycle and there are wide variety of options in stainless steel, so based on the application and utility, the right grades if chosen, they are not expensive, and in the long run, they are already saving the cost. Okay, thanks.
So thank you very much. Thank you very much, Mr. Devgan, for sharing these slides at a short notice of half an hour, because two of our panelists had declined to attend the panel. So I requested him to share some substitution efforts of General Stainless in the chemical sector. So thank you very much for doing a very good job. So there, you can understand that how many sectors have actually gained by changing over from mild steel to stainless steel, or lower grade of stainless steel to a higher grade of stainless steel. So this trend shall continue, and if we have to make our GDP not suffer due to corrosion loss, I think all of us should start thinking in terms of finding solutions to corrosion. I'm not saying use only stainless steel, but as it seems, stainless steel ends up being the preferred and easier choice, and fit and forget kind of a solution. So with that, we come to the end of this session on stainless steel for chemical, fertilizer, and petrochemical industry. We hope you enjoyed listening to the enlightened speakers here. And what is most important is that the corrosion management strategy or policy or systems to be included in the daily worksheet of all the organizations going forward is something that is going to happen. And this is something which should cheer the hearts of stainless steel producers, and also those who provide coating solutions or any other type of solutions to fight corrosion, depending on the expectation of the life cycle. So thank you very much for your patient listening. And I only saw the audience numbers swell they did not reduce, and that was very encouraging. So thank you very much for your participation. Any questions you have? Sorry, any questions? Any questions from the audience? To any one of the panelists? Okay. Ms. Nagma Sinha wants to ask. Yeah, before she asks the question, I must tell you a bit about Ms. Nagma Sinha. She joined Outokumpu from travel industry. And today she is the sales manager for Outokumpu special steel products to customers in southern part of the country. So imagine, we talk about empowering ladies or the power of a lady. I think in a span of 8 years, she has graduated from a travel portal to I think the most advanced stainless steel company in the world. Okay, ask your question. Thank you.
Thank you very much. Yeah, good evening, everyone. Actually, I do not have a question, but it was a comment. I would just like to say that it's very encouraging to see that both chemical and petrochemical industry is consciously looking at various stainless steel applications. That is a very good news. And with the success stories that Mr. Devgan was showing, I think stainless steel manufacturers like us, like Outokumpu and Jindal and various others, can work together with process licensors and especially with EIL and see where we can use these special material. Especially when it comes to what we heard about having an original MOC for certain products, which was stainless steel, but we looked into improving and bringing superior material for longer life. So I think that also plays a very important role. So it's very encouraging. Thank you very much.
Thank you very much for a very positive comment. But I must reassure the audience that this national mission, which is supported by Jindal, but also the participation is there from across the sector, be it the coating industry or material science companies, R&D labs. Very soon you will have experts available. If you have a problem in chemical sector and you want a solution, you would be having a number to dial or an email address to write to, and within 24 or 48 hours, you will find a solution, or he will start engaging with you to find a solution together. So that's the kind of ambition we have, which should happen in the next couple of years.
I have a small question for the panel. We touch the technical aspects, we touch the corrosion aspects, but I think that the market sizing aspect got missed. India is poised to become the Asia hub for chemical industry, and there's a lot happening on the policy framework on that side. What is the size of growth that we are looking at, and what is the opportunity that it will create for the stainless steel industry in terms of new capacity addition?
You see, as I said in the initial remarks, that we are already third in the Asia, and be it fertilizer, be it chemical industry, and our ambition is to become bigger. So, and then we have lined up new projects or new investments in the next 10 years. And looking at the kind of corrosion problems the industry has faced, and they are migrating from corrosion-prone products to using corrosion-resistant products in a big way, I think going forward, there is going to be a huge demand to protect the existing assets, and also the new assets which are going to be created would have material selection as a very, very important aspect in design, and which would kickstart a good demand for higher grade of stainless steels for the chemical sector. So net, going forward, I see a quantum leap in terms of demand for special steels from the chemical, petrochemical, specialty, and fertilizer industry.
And Ms. Suri, how much of this do you see as an organic expansion of the current existing strengths? I mean, fertilizers going from point X to 2X, and how much will be new categories which have not happened in India till now in the chemical and petrochemical space, but will be new inductees?
You see, unfortunately, one of the speakers from Aarti Industries, he could not make it. I think he developed some stage fear. He said, I'm not well, so I will not be able to join. But Aarti Industries is very, very advanced in terms of innovations in specialty chemicals. So if we had somebody from Aarti Industries talking to the audience, we would have learned much more. Because this sector, as I said in my initial remarks, is such a wide spectrum that expecting Mr. Suri to give you an answer would be very, very, I would say, another ambitious expectation from you. So
let's open it to the panel then.
Okay. Now another Mr. Raghav from specialty chemical sector, please.
So if I talk about in the industry size, so chemical industry was roughly around 280 or 250 billion dollars in the past years. Expected to reach by 300 billion at around 2025 and $1 trillion by 2030. Okay, this is the market growth that a chemical company is exploring. In terms of particularly SRF, if I talk about, I joined it 16 years back, and every year since then we have been putting almost 2 projects in a year with a rough investment of around 400 to 500 crore. We started our Dahej Greenfield facility almost 10 years back, and almost around 3,000 or 3,500 CR plus investment has already gone in. And what we are seeing currently is that we are out of land maybe in couple of 2-3 years. So this is about the investment. If I talk about in terms of stainless steel percentage in overall usage, my one multi-purpose plant with a capacity of around 800 odd equipments employs roughly like 4,000 to 5,000 tons of piping. And if I talk about in total equipment inclusive, valves inclusive, stainless steel valves, stainless steel equipments, roughly 60,000 odd metric tons of material which goes in one plant. So this is how the...
Fantastic. I think this is what the audience needed. I think we were too much focused around corrosion. Team GSL, I have one question for you. Fertilizers will move to nano fertilizers now. Agrochemicals, the conventional ones, will move to more sustainable forms now. What kind of product innovation focus will GSL put on that?
Yeah, recently we have seen a trend that basically clients from the fertilizer industry who were into urea basically, now more focus is on DAP, neem coated and other varieties, advanced fertilizer basically. Our government is also investing on DAP and other areas. There the more and more, because as the process become more and more complex, the metallurgy elevates. Because as the process is more complex, you get more like corrosive chemicals in the process. So basically, as recently, like in previous 2 or 3 years, since last 5 years, there is a more trend of usage of higher alloys, which like typically earlier 304 used to suffice, then people have moved to lean duplex, as I mentioned in slide, or maybe higher like duplex, 317L. So grade elevation is there. And being in country's largest stainless steel and having a robust R&D facilities, we are also basically continuously working closely with the various manufacturer and the user. Wherein there are, I will share one case. One of the fertilizer manufacturer, a big one I won't name, in Mumbai. So they were coming up with one project. So when their consultant contacted us, they said, boss, when we are approaching various fabricators or the process owners, someone is suggesting some material, someone is suggesting some material. Could you help us out? Then we said, okay, what we can do, you give us the feed, which will be in the process. So with that feed, we said we will do testing And you also will share the methodology you test, and the result we will share. And let you and your client decide. Then we tested it, we agreed on a procedure, okay, this we will test, and these are the results. When the results were there, then basically they were able to reduce the cost also, they were able to select the right material, and it was basically, they were able to take a right decision, a conscious decision that, okay, this material we have to choose, and with this we will get this much life. So those kind of consultative effort along with the industry, because most of the things as newer technologies are coming. One is like something is working in Europe, it will work in India, but the climate condition, other environments are different. So it has to be a country-specific, region-specific, or the process and location-specific solution. That's why our focus is more on the consultative selling, rather than suggesting, okay, boss, this process, this will work. Because it is not like that, there are various aspects to it. So in this way, we are working towards basically closely with the industry, what is right for that application, that we jointly work out.
Thank you. One last small one. Beyond corrosion, what will be the other elements which will decide the absorption of stainless steel in the years to come?
One is corrosion. One is basically your hygiene factor, because as you go, hygiene is another important area. Then there is a contamination, like in pharma. The contamination is a bigger concern. So that is also one area. Other than that, I would say like the value of the material, or the in terms of like a pressed kind of thing. Like one example I will share in the similar, it is same from the fertilizer industry, this DAP plants that are coming. So when we interacted with same one fertilizer based in Gujarat, so they are coming up with a plant. They said it is a cyclonic prone area. So because of cyclone, what we have faced earlier, like our roof sheets, during the cyclone, they are gone. So there they said, we want to go with stainless steel. So can you help us out? Then there what we did, we tie up with one of their, like there's a technology called standing seam. They said we don't want it to be screwed, because if there is a screw, there is a hole, there will be leakage, and it will be, again, it won't serve. Then we tied up with one of the standing seam, who could do the standing seam people, like PEB manufacturer. They did it, and now basically that sample is submitted. They are now, what will happen with this? That fertilizer company contacted 3 more this PEB manufacturer. Boss, I want in stainless steel and in standing seam. This is a solution we have. This is a prototype. Now they're all trying. So with this kind of effort, joint effort, industry, manufacturer, and technology provider, when these are done, definitely new avenues are open for the manufacturer, and new solutions which are lasting. So it could be, one is corrosion, other could be the utility point of view. What is that's why consultative kind of thing is more important rather than suggesting something.
To add to his points, you see, aesthetics, the beauty of stainless steel is very important when it comes to your architecture and building segment. Other than that, we are talking about mobility. So in mobility, if you want to get mileage kitna deti hai? So if you reduce the weight of the car can go for extra miles, be it electrical mobility or be it the engine, your gas-based or your petrol and diesel-based. So high-strength stainless steels are the emerging new segment, which is going to be used extensively in railways, motor cars, two-wheelers. So that is another application which is going to emerge. And it also goes in line with sustainability, which says consume less. So if you are consuming less stainless steel per car, so definitely you are taking a big step towards sustainability, towards a sustainable world. So there are many innovations going on around the world with respect to stainless steel in different segments. And some of them we saw, many of them we have missed, in the oil discussion. It was mainly on green hydrogen, but nothing much was talked about either by IOCL or by NTPC on stainless steel actually, how so much of failures that they are witnessing can be controlled by switching over to stainless steel. They are still very conservative, so they need to be very aggressive. So, but then, whether it is Jindal Stainless or Outokumpu, they are doing their best to educate them, and that's very important. Once the other guy, the top management and the lower management, they get educated on the beauty of a sustainable solution, then they accept it. And then, using it becomes very easy. So they are all struggling and they are all doing their best. Like Mrs. Sharma said, that although it is not mandatory in the GFR, that is government's finance rules, to look at life cycle cost, but she said you can always threaten the people that look here, tomorrow if it is found that you have actually spent more national money than what you should have spent by not resorting to LCC analysis, you could lose your job. So there could be an investigation instituted by CVC against you. So if you talk like this to them, then they will start thinking, okay, let me review whether LCC is the right. So there are so many factors which can lead to more use of stainless steel in different applications.
Thank you so much.
Thank you.
Sorry, maybe I'll give you ammunition for your next point. All through the last 2 days, I've been hearing about corrosion, I've been hearing about the lightweight thing, and I'm a layman to the industry. To me as an outsider, this is also one of the lowest carbon emission production materials. Fine, and nobody's highlighting that. Fine. So any mother dairy, any SRF, any Pfizer, when they're setting up the plant, you tell them that here I have a material which brings down your emission costs down from the project setup stage. It's a big offset. It's a big carbon advantage for them. So why is the industry not pushing that spiel?
Right. Just I would like to add that in terms of carbon footprint, stainless steel carbon footprint are much lower.
It's the lowest, I would presume.
Okay. Stainless steel carbon footprint are much lower. One is basically its recyclability. And basically, if you compared with other processes, process route is also optimized. Secondly, you get a longer life. Suppose you choose a metal which is live for around 100 years or 50 years of life, and during that period you have a 5 recycling, or you have to repair or basically replace 5 times. So that is your carbon footprint would be reduced. And at the end of life, basically, you get a salvage value. It won't be going 100% to the scrap. It is recyclable. Secondly, one study we did for Indian Railways, wherein these wagons, basically with wagons, because since it is a moving equipment and since they are with stainless steel, so the carbon footprint of over the period of 35-year life, it is much less than the carbon steel wagons. So that study we did, and it was done by E&Y. So multiple areas, because this is one example. But definitely owing to the lower carbon footprint and the equipments or the facilities which use more stainless steel or the material with lower carbon footprint, definitely their carbon will be, emission will be reduced. And there is a recently Europe more focuses on the green steel or the carbon. Definitely, as being India, here also this will come. And
that is where I was leading.
Yeah.
That the ESG compliance pressure for disclosures will require the producers to start declaring their production processes, which will mean they will move to hygienic, they'll move to safer, they'll move to more transparent materials, which many of them try and avoid, unless you're in an industry which cannot survive without stainless steel. So there are many which are in the optional category. The ones in the optional category with their ESG compliances will start moving towards stainless steel. So that's another market segment which will open up.
Sukhjinder, to be very frank, yesterday Tim Collins, he talked about emissions. And that is the first time I have spent decades in the stainless steel industry. And I never claimed that I know everything about stainless steel. But then I do claim that I am keeping my ears open. So it was a very good point I understood yesterday, which going forward, yes, you're absolutely right. We need to talk more about emissions as well, while talking about other attributes and life cycle cost element. Thank you for reminding us.
Thank you so much. It was lovely having you here, and it was a very, very informative session. I think I've been able to motivate one more question.
Yes, good evening all. I am Nisarg Sheth from Reliance Jamnagar. I am from Refinery Petrochemical Complex from Corrosion and Inspection. I want to share one view. We are talking so much about switching to duplex, super duplex stainless steel. But my personal opinion here is that we as a country are facing a lot of challenges with respect to the quality control of duplex stainless steel on the as bought out products, plus the fabrication challenges are also there, because at Jamnagar we have a huge quantum of duplex and super duplex stainless steel, and I'll say more than 95% of root causes for the failures are predominantly due to the what we say the fabrication practices which were not correct, or the heat treatment or XYZ anomalies which were found at the manufacturer ends. So we have very simple seawater services related failures which we are observing prematurely in super duplex, duplex stainless steel, so which is not intended. So we went to that metallurgy to keeping in mind this life cycle cost analysis and all. Earlier, anti-resist was the best metallurgy suited, we all know. But the industry shifted from anti-resist to super duplex, duplex, keeping in mind that we will have an enhanced life. But due to these reasons, again we are back to the square. So as together we need to work in this aspect as well.
You see, if you were there when I was presenting my slides, I did mention that besides material selection, welding is also very important. Fabrication is also very important, because you are not the only one saying this. I remember people from Hindustan Petroleum, Visakhapatnam, also said, we shifted from 316 to 2205, but it failed very fast. Then what failed? He said welding. So welding also is very important. If you are using 2101 stainless steel, you should be using 2205 welding rod, one stage higher, which many people don't know. So therefore, when you buy any special steel, you please ask the material supplier to give you the full information on fabrication techniques to be followed. And then you will not face this problem. But having said that, I must acknowledge here that we had the opportunity of listening to Dr. Jani from your corrosion management team, and the audience must know that the Jamnagar plant has the best corrosion management system in the country, and they are the pioneers, and I must give you a clap for that.
Can you hear me? I was responsible for introducing duplex stainless steel and super duplex stainless steel and hyper duplex in India. There have been a lot of success in the past, but last 10 years, I am finding a lot of complaints. The main reason is that most of when the volume of fabrication increased, new players came in, and the fabricator selector or vendor selection was not correct. We have not checked whether they are understood the duplex stainless steels well, and are they capable of absorbing all the precautions without fail, and or the design check was done before it was released for fabrication. Quite often they treat it like a stainless steel because it looks like austenitic stainless steel, so they treat it like an austenitic stainless steel. This is the basic root cause, and they have become overconfident to carry out all the operations as if it isn't 304L or 316L. But there are some nuances, there are some differences that ought to be recognized, and when it is done, there is no issue. For HPCL, for example, most of the failures occurred on the heat exchanger flanges. That's because the flange location is a crevice. The pitting resistance index, the crevice resistance and pitting resistance are different. But for the same temperature, the critical pitting temperature and critical cervix temperatures are different. If you are designing only for pitting, and if you are not avoided any crevices, it will fail. In case if the layout, the the interior finish, the welding, everything has to be done in such a way there is no crevice formation will occur, or no settlement will occur of any solids below which the under deposit crevice corrosion can occur. These are the two reasons. And in the flange faces, because crevice corrosion is there, the PRE has to be increased by giving a higher deposit of a different material with a higher pitting resistance index. And the heat input condition restrictions to give the balance and avoid the segregation of the elements, like especially molybdenum, is not understood by people. And once it is done, and you can't blame the material, you have to blame the fabricator. And that's where your quality assurance group or quality assurance group must play a part in the vendor selection and auditing their procedures before you give the order. If this is done, most of the problems will be solved.
I have got my experience to be shared with you. There is 2507 super duplex stainless steel, which was to be utilized for one of the distillation column. While fabricating that material, as normal, people feel that it has to be preheated before the welding is to be carried out, which is a negative point for 2507. Without going in detail of the observation made by the fabricators, they did the heating and it led to the welding failure. And that is an important aspect to be considered when you go for a super duplex stainless steel. This is the experience only.
I'll give you a very simple experience. I went to the Industry Research Center of IIT Bombay. And as I was entering the building, there was railing. And the railing was corroding. It was stainless steel, but it was corroding. So I was quite surprised because anywhere I see stainless steel corroding, I feel very bad. And so I went and asked the professor, I said, you have a research center, and what kind of a railing have you used? He said, well, we must have used 316 and all that. But then they did not specify that the railing should be polished. The railing was rough, and the rough railing was attracting dust to settle. And that settlement of dust led to corrosion and led to the whole thing looking ugly. So it is also very important that for any external environment you use stainless steel, it should be polished, it should be shining, otherwise it will start corroding. Even if you use duplex stainless steel, it may start corroding. So there are minor things which you must keep in mind, and only the supplier of the material can give you this guidance. If you buy from a trader, then you will have all these problems that you are talking about. Thank you.
Thank you so much, panelists. That was a very, very informative session. Thank you for your valuable time, your knowledge. It's years of wisdom and experience which you've been able to condense into this hour and a half. I'm sure the industry has a lot of takeaways. And please connect with them during the remaining of the evening. We have one more small session to go. After that, we are having the ISSDA Excellence Awards for Stainless Steel Industry, which will be followed by cocktails and dinners. Network with the panelists. There's years of experience. Benefit from the convergence. Talk to them. Thank you so much.